Okay, so having talked about this idea of interior versus exterior for simple curves, the natural question to ask is there some way to extend this idea to um, non-simple curves, right, where they have self-intersections? Okay, so this naturally leads to the idea of winding number. Okay, so a natural extension to non-simple curves, right, is the notion of a winding number. Okay, so if you're given now just a closed curve, not necessarily simple, with the property that you can define a winding number. It's like for x, which is not in the image, it's like of that curve. So if x is not in the image, okay, then you can consider the following map from now S2 to itself. Let's call it x gamma bar, for lack of a better term. So it's, sorry, S1 to S1. Okay, so now it's a map from the unit circle back to itself. And essentially what you do is that you shift it's like the curve so that you think of the x point as the origin. It's like, and then you normalize that vector. Okay, so gamma bar, it's like of s is just gamma s minus x. So I've shifted it so that x is the origin. And then I divide by the norm of this vector, which I can do because I've assumed that x is not in the image of gamma. Okay, so now this gives me a map from S1 to S1, and you can ask as you go around the circle, how many times it's like this, you're winding around the circle, right? And then, so whenever time you complete a full turn, it's like you sort of, you count it as +1 if it's counterclockwise and -1 if it's clockwise, and then you sort of sum it all up, right? So when this completes a full turn, right, we count it as +1, right, if counterclockwise, and then -1 if clockwise, and then the sum of these is the winding number, which is always an integer. Okay. Okay. So so that's sort of this idea of a winding number. Okay. So you might ask, well, what happens in the special case? It's where the curve is simple, where the closed curve is simple, and how does it then relate to this idea of interior versus exterior, which comes from the Jordan curve theorem. Okay, all right. So if gamma is simple, right, then all the interior points have the same winding number. And that number is either going to be plus or -1, depending essentially on the orientation it's like of gamma of the S1. So either +1 or -1. Okay. So in order to just specialize it to one case, it's if you end up with a situation where it's -1, you can reflect this copy of S1, and then it just reduces the case where you get a +1, right? So by reflecting sort of S1, right, we can reduce this to one case. All right, so in that situation then, the following is true. Okay, so let me denote this winding number by W, right? So W of gamma, so the winding number of the curve gamma, it's like about point X, right? It's going to be the following. So it's going to be +1 if X is in the interior. And then it's going to be 0 if X is in the exterior. Okay, so this gives you another characterization of the idea of interior versus exterior in terms of this idea of a winding number. Okay, so you might ask, okay, well, yes, we have this idea of a winding number. It agrees, it's like with, or it's compatible, or it encodes in some sense the same information about interior versus exterior as we had talked about before. But what happens now if it's sort of non-simple? Okay, so the point is that if it's non-simple, you still, of course, have a integer winding number, but the integer winding number doesn't have to be either 0 or 1. It can be any integer. Okay. So for non-simple curves, we can get sort of other non-integer. Sorry, no, sorry. You can get other integer values of winding number besides, say, 0 or 1, or ±1 if we haven't gotten rid of that other case having to do with the orientation of S1. Okay. So let's sort of give you a simple example of this, right? So of course, if I had a curve which does something like this, right? But then at some point in time it crosses, right? So this, if you can imagine, right, we'll have done one complete. Okay, so let's just make life easier. Let's look at what happens here, right? So starting from this point here, we've gone around once, twice, right? And then, okay, actually, let me try that again. All right, let's start from the inside, right? Okay, so going around this way, we've done it once. Going from here to here, we've done it a second time. We've gone around a second time, right? Going from here to here, we've crossed a third time. And you come back here, and you've done a complete thing, 4, right? So this has winding number 4, right? So here, if you look at this as the point, it's like we have, so this point here, okay, we call that x, right? Then w of gamma x, right, is equal to 4. And that's obviously not a 0, 1, or -1, right? You've been allowed to do this. It's like because now it's like you have this curve which does self-intersect. Okay. All right. So anyhow, so that's just a simple example. It's like of okay, so there are actually 4, right? It gives you a simple example of a curve, a non-simple curve. It's like with a winding number. It's like associated one of the points, which is something besides, again, 0, 1, or -1. Okay, so let me just stop here.